So in handout 3.1, we talked about a measure of location, but more specifically, a measure of center. So mean, median, mode, geometric mean, and the weighted mean. Right? So all those five things are trying to describe where the center is in a distribution. Okay. Now, percentile is also a measure of location, but we're no longer talking about the center. Right? Percentile, a percentile, most of you might have heard about this in, if you ever taken the SAT, right, or look at the test score. Right? So for example, right, if I say the 80th percentile of income in San Francisco is $90,000. What that means is that 80% of the people make $90,000 or less. Okay, so we start from the smallest value, go over to the largest value, whatever the percentile is, and the percentile gives you a percentage people that makes or that's in that range, the distribution that's in that range, right? For another example, right, I could say the 20th percentile of height is 4 foot 5 inches. 4 feet 5 inches. Okay, so that means 20% of the people or 20% of the population are 4 feet 5 inches or less or shorter. Right. Right. Okay, and we're already seeing a percentile, and that is the median. So a median is a measure of center, but it's also a percentile. Right? A median is the 50th percentile. Right? So at the median, 50% of the population is below the median, and 50% of the population is above the median. Okay, so to calculate percentile, we'll go a couple of steps here actually. First, the data must be in ascending order. Second, we calculate this thing called LP, and that's basically the location of where we will find the pth percentile. The P is the percentile that we're interested in. Right? And then once we calculated that, right, then we have a couple choices. So we have some decisions to make. So if it's a decimal, then we find the difference of the next two number. Okay, and the idea of that is because we are finding where the percentile is between the next two numbers, somewhere between the next two numbers. Okay, it's better explained with an example. All right, so let's give it a try. Let's find the 80th percentile. Okay, first we need the sample size. So go ahead and give it a count, right, and find the sample size here. Okay, the sample size is 70. Okay, next I want to find the 80th percentile. So I'm going to go ahead and calculate my LP. So I'm going to calculate the L80. Okay, and this will again find the location. This will tell me which position out of 70 I should look for the 80th percentile. Okay, and it's very simple. Formula is more than we need really. It's just you take 80 divided by 100, so that's 0.8. Right? And then now you multiply by, and here's the tricky part, 70 plus 1, so n plus 1. Okay, again, that's 0.8 times 71. Right? Okay, and you put that in the calculator, and this is what you get. All right, now 56.8. All right, so let's look for the 56.8th position. Okay, this is the location, right, of the location of the 80th percentile. All right. Okay. So now we're gonna just basically count down. Right. You can keep counting down 1, 2, 3, 4, 5, and go find the 56. And here we go. So we found that the 56, if you count correctly, 56 should be over here, 635. Okay. Now the location is actually 56.8. Okay, so you can imagine, all right, good thing we have some space in between. It's actually here. All right, the 80th percentile is a little bit over here. Now, how do I get that number? Right? So if this was 56, just 56, with no decimals, then boom, right? 635 would be our 80th percentile. Okay, but I have this 0.8 here. Okay, so now to get that 0.8, the idea is, right? First I find the distance. right, of those two numbers. So I find the 56 and the 57. Let's write that down. First, 56 number is 635. 57th number is 649. Okay. Now, so the first I find was how far is the distance between them, right? Kind of like this. 635 is here, and then 649 is here. So overall distance between them is 14. So I take 649 minus 635. I get 14, right? And I have this 0.8. So basically I want 0.8 of 14. So here is 0.8. I want 0.8 of 14. So I just take 0.8 multiply by 14, and then I get 11.2. Okay. All right. So the idea here is that to find the 80th percentile, I'm going to look at the 56th position, which is 635, and then I'm going to add 11.2 because I'm not quite there yet. So I'm going a little bit further, right, to 56.8. So I'm gonna add this 11.2. So I'm gonna find the distance here. Okay. So my actual 80th percentile is 635 plus 11.2. Right. So 80th percentile. Right, equals 635 plus 11.2, which equals 646.2. Okay, I have to say a disclaimer here. This is an approximation, right? Because this is a sample. Okay, this is a sample, right? And we're trying to approximate, we're trying to estimate that in the population, what is the what is the 80th percentile. And there are a few things in statistics that is not universally agreed upon. Okay, so this technique, right, is from your textbook. However, you're going to find other textbooks, right, that doesn't quite use these techniques. Okay, they are in a different textbook that I've seen. Whenever you get beyond, like for example, if you get 56.8, another one, another textbook just simply find the difference. Find the center. Okay, they don't bother with this 0.8, right? Or some textbook just simply add 1, so 57. So that's even easier, right? If to make easier, so you could just go up to 57, and so that means 649 will be the 80th percentile. Okay, a lot of this have to do with how the percentile is defined, right? So in some textbooks, percentile is defined that a percentage of population that is less than this number. Right. Well, if that's the case, right, then we can, if we use 649 as the 80th percentile, that's not too bad of an approximation. Right. So this is one of those unfortunate times where it's not an exact science, right? And many different sources have the freedom to do what they want. Right? So in our class, so I mentioned this here. So in your exercises. Right, in your exercises, the textbook will follow, should be following this, but what you will see is I will make a tutorial, because when you do this on Google Sheets, which I want you to do this on Google Sheets, you will get a slightly different value. Okay, so don't be alarmed, right? If you get something slightly different. Okay, it's just the way that things are. Right, different organizations have different way of finding percentiles. Okay, so we do this mostly to just to practice and learn the concept and the idea of what a percentile is. You will rarely ever have to do this calculation. Okay, because we'll be doing most of this. On the computer using a statistical software. And this is what I mentioned, why that it is important that you know what the program that you are doing is doing. How is it programmed, right? Because when you type in a program, just say percentile, like it's already pre-programmed, and so you need to be able to interpret the result. Okay. All right. Now, quartiles. So quartiles are simply special cases of percentile. Right? They're just percentiles that we use very often. So the quartiles are naturally first quartile, so is the 25th percentile. Second quartile is the 50th percentile, and the third quartile is the 75th percentile. Okay, all right. So let's do for practice, right? We'll go ahead and use the above formula and go ahead and calculate Q1, Q2, and Q3. Okay. Now, first thing I'll do is just calculate the L. So here, I'm going to go ahead and calculate the L, which is the location of or the LP as we call it, right? The location of the percentile. Okay, and you can pause and check your answer when you're done. Okay, so we have our L, right? And these are all just the location in our data set where we would find we would try to locate and get an estimate of these percentiles. Right? So L, and remember, right? These are just 25 divided by 100 times n plus 1, which is 71. Now, since Q1 is 17.75, right? Then we need to find the 17th and the 18th number. Okay, so let's go ahead and look up into our data set and then find out what those two are. Okay, so if you do the count, right, then you realize 17 and 18, they're both 545, right? So the difference between them is going to be 0. So you just basically, the 0.75 will be multiplied by the 0. So the 0.75 then is irrelevant, right? Visually, here, right, 17 and 18, right, that is these two numbers, 545 and 545, right? Again, the 25th percentile, it is 0.75, so it's 3/4 of the way here, right? It's actually over there. Okay. Now, since the idea is this whole range here is 545, then Q1 must be 545. Okay. Let's look at Q2. All right. Let's see what Q2 is. So Q2, we're looking for the 35th position. Again, okay, 1, 2, 30, 31, 2, 1, 2, 3, 4, 5. Okay. 35th position, so we're looking for the 35th and the 36th. Again, these two are the same number. Lucky us, right? We don't have to deal with that 0.5. So Q2 is just going to be 575. Okay, let's look at Q3. Q3, right, we're looking for the 53rd position. Okay, and so now we're going to look for 53 and 53rd and 54th location. Okay, and so that's going to be, so if you count correctly, okay, and feel free to pause if you want to try on your own. But that's going to be here, right? 53rd and 53rd and 54th. So that's going to be 625 and 625, right? So again, 1, 2, 3. That's going to be these two numbers. Okay, lucky us, right? So we don't need to find any difference there. If I were to write it out, right? The entire calculation, I'll probably write it out like this. 625, right? This is the 53rd position, plus 625 minus 625. Okay, so here, I'm going to write it out in detail, see what's going on here. Okay, this is the 53rd position, this is the 54th, and then this is the 53rd. Okay, the reason why we're doing this is because the location, right, that we calculated is 53.25. Okay, minus these two times by 0.25. Okay, and then subtract these two, and then we're going to get 625 because this is 0. To find the quartiles, there is an alternative method. Okay, now this method is very popular. I know that all of the TI calculators have this pre-programmed in. I believe the Google Sheet or Excel might also be doing it this way. Okay, but so the alternative method here only works for quartiles. Okay, so it will not work. As you'll see in a moment, it will not work for other percentiles, but for quartiles, which is what you'll likely calculate most of the time, this alternative method works. Okay, I like it because it's very intuitive, and it is much faster than the other method. Okay, and I like it that I like that because the quartiles, right, essentially is just cutting the data set into 4 pieces. Okay, so the alternative method, the first step, let's find the median, right? Basically, cut in half. Right? So find the median. Now we know that this is n equals 70, right? So n equals 70 and n divided by 2 equals 70 over 2, that is 35. Okay, so we know that we can cut the data in half completely. So let's just count. Let's go to 35. 1, 2, 3. 1, 2, 3, 4, 5. Okay, so the median, it is here. So if we can, I want to illustrate, half the data set is there above. Half the data set is there above, and half the data set is below. Okay, so what is the median? Oh, it's obvious. All right, I want to take the average of these two numbers, 575. So Q2 equals 575. Okay, bam, very quick. Next, to find Q1, okay, I'm simply going to find the median of the first half. So I'm going to just basically ignore the bottom half here. I'm going to look at the first half. Now, the first half, I have my sample size is 35. Okay, so I'm going to take 35 divided by 2, right? And that is going to give me 17.5. So here we go, 10. 1, 2, 3, 4, 5, 6, 17, 18, right? 545, that's going to be my Q1 again, right? So this is 17.5. So I know my median will be the 18th position, okay? Because my sample size is an odd number, okay? Very quick, right? Now let's look at Q3. For Q3, right, it's the median of the second half. Right? So I'm going to ignore the top half. I'm going to look at the second half, and look, luckily, right, the median is the same. I'm sorry, the data set is the same number, so it's also 35 divided by 2, which will give me 17.5. Okay, and so I'll just count, right? I'll just count down here. Okay, here we go. 10, right? 10, 15, 16, 17, 18, 18. Okay, 18. There we go. 625. Boom. Okay, and that's it. That is the alternative method. Hey, I might have went a little quick there, but just keep in mind, all you're doing is just finding the median. So go back to handout 3.1, look at the rules, what happens when there is an even number of samples or observations, or if there is an odd number of observations, okay? And so that's all we're doing here. You're just finding the median. First, we find the median of the whole set, and then the median of the first half, and then the median of the second half. And that will give you your quartiles, okay? All right. So that's all for measure of location. Okay. Now, right, we're going to move into measure of variability.